are going to build and draw this problem. Students were collecting pieces of rubbish from the beach. In week 1, they collected 1,372 pieces of rubbish from the beach. The next week, the students collected 719 pieces of rubbish from the beach. How much rubbish did the students collect in these 2 weeks? 2 efficient tools for this problem are place value disc and a place value chart, and the second is a number line. Pause the video and discuss with people around you, why are these efficient tools, and why would other tools maybe not be as efficient? Pause the video now. You might have talked about how place value discs are much easier than base 10 blocks, because as we get into larger numbers, base 10 blocks are not as efficient. A number line is another efficient tool because you can build on it as well as draw with it. So now, build this problem. You choose which tool you want to use, place value disc and place value chart, or the number line. Pause now and build the problem. Let's see how you did. I tried the place value chart first with my discs. I built the first number, 1,372, and the second number, 719. And I'm going to put these together to find out how much rubbish altogether. I notice when I have all my ones, there's a lot. There's more than 10. What do I need to do? What did you do? Well, I know that I can trade 10 of those to make a 10. And if I make 10, I still have 11. 9 and 2 is 11. But I can't keep this in the ones. I need to move it to the 10s. So when I put all the 10s together, I notice again, I have 3, 6, 9. Well, that's not 10, so that's fine. I put my hundreds together, 2, 4, 6, 8, 10. Ooh, 10 hundreds is how much? It's 1,000. I'm gonna trade that 10 hundreds for 1,000, and this gives me my total answer. I had 1,000, 0 hundreds, 9 tens, and 1 1. So for my first thinking, I got 1,091. I want to check it with another build today, or you can check it using some numbers. So we're trying to try both of these tools today. So once you've done it with one tool, switch to the other and see if you can do it again and build it again another way. Pause the video now and see if you can try the other way. Did you get the same answer as your first build? I'm going to try it. I'm going to start with the larger number because that's more efficient and easier to add up. I'm going to do it this way. I know I had 1,372. I now need to add 719. Well, for me, and there's many ways you can do this, but for me, I'm going to jump the 700 first because I think that's easy. If I add 700 here to 300, that's going to be 1,000. So I'm going to have 2,000. I'm already noticing I have a mistake. And I can see why. Did you see it in my video? Let's keep going and see if you can figure it out. Okay, and then I have 19. 19 is really close to 20. So right now I have 2,072 because I added the 700 and 300. But 719 is so close. I did the 700. Now the 19, I could just do plus 20. That's easy for me. And that would be 2,092. But then I know that I did 20 and really I want 19. So I'm gonna minus 1 here and that would give me 2,091. Okay, let's compare that to my first thinking. And what do you see might have been my mistake? Did you see it when I was first talking? Look, I have 2,091 here. There's the 91 and no hundreds. But I only said 1 and there's actually 2 there. So by checking my work, I can see that I'm accurate now, and I know that was a little mistake. This is why mathematicians solve things more than one way to check that they're accurate. Now I want to draw a math model of this problem. I could draw what I did with place value discs. I could draw what I did with number line. That could also be a draw if I draw my own number line. But I'm going to challenge myself with a new model, and that is called a tape diagram or a bar diagram. And it goes like this. I know in week 1, there were 1,372 pieces of rubbish, okay? And in week 2, I'll put week 2 over here and label it. Mathematicians always label their thinking. There were 719. And I wanted to figure out that in total, which I did, and I've checked my work already, was 2,091 when I put it together. Pause the video and discuss why this math model of drawing really shows this problem and what my thinking is. Pause the video and discuss now. You might have noticed that there is a part whole. The two parts are the same size as the whole. If I wanted to be a little bit more accurate, I could have made my line for the part whole go here, because this part is a little bit bigger. Either way, it is still accurate because it shows my thinking, and I've labeled. I might label a T for total to make it even stronger. How will you draw this problem? I've shown you one way, now you try to think of another way. This problem is not finished yet. The students continued to collect rubbish. In week 3, they collected this many pieces of rubbish, and in week 4, they collected this many pieces of rubbish. How much rubbish in weeks 3 and 4 did they collect altogether? Go ahead and decide if you're going to build with place value discs and the place value chart or the number line. Then check your work. Think of how you could draw the problem as well. When you finish that, I have a challenge for you. How much rubbish did the students collect in all 4 weeks together? How could you build that, and how could you draw that in a math model? Go ahead and give this problem a go. Pause the video so you can see the numbers and thinking. How did you build and draw this problem? I wanted to show you one way to think about the draw part. It does not look like my build at all, but I continued what I did last time. I thought, I knew weeks 1 and 2, and I had a tape diagram or bar model already like that, so I thought I'll just add on to it. Here is week 3 and week 4, so I have 1, 2, 3, 4 parts. Since I already knew week 1 and 2, I just had to calculate week 3 and 4. When I put those together, I got 3,422. Then I put weeks 1 and 2 with weeks 3 and 4 and got 5,513 is my total, T for total. Are my calculations accurate? Did you get the same?